Phenols. If OH group is directly attached to the benzene ring, we call it as a phenol. If it is attached to the ortho position, we call it as a orthocresol. If it is attached to the meta position, we call it as a metacresol. If CH3 is attached to the para position, we call it as a paracresol. And dihydroxyphenol. If benzene ring contain two hydroxy group, we call it as a dihydroxyphenol. Its general name is catechol, and this name is resorcinol, and this we call it as a quinol. And trihydroxyphenol. If benzene ring contain three hydroxy group, we call it as a pyrogalal. And benzene 1, 2, 4 triol and phenyl glycinol is the example of trihydroxyphenol. Creation of phenol from aryl halides. When benzene is treated with the sodium hydroxide, it gives sodium phenoxide. Followed by acidification, it gives phenol. And preparation of phenol from benzene sulfonic acid. When benzene sulfonic acid is treated with the alkalis and followed by hydrolysis, in the presence of acid, it gives phenols. And preparation of phenol from diazonium salt. When aniline is treated with the sodium nitrate and HCl at 0 to 5 degrees Celsius, it gives diazonium salt. When benzene is treated with the sodium nitrate and HCl at 0 to 5 degrees Celsius, it gives diazonium salt, and it is called as diazonisation. When diazonium chloride is hydrolyzed, it gives phenols. When cumin is oxidized in the presence of atmospheric oxygen, it gives cumin peroxide or cumin hydroperoxide. On hydrolysis, it gives phenols. It is also called as a cumin hydroperoxide, and it is involved in a free radical mechanism. When sodium salicylate is treated with the NaOH or CaO, means sodium hydroxide or calcium oxide, commonly called as a soda lime, it gives phenol. And chemical properties of phenols. Phenols possess acidic nature due to donation of proton. And order of acidic nature. Carboxylic acid is greater than, phenol is greater than, methanol is greater than water. Water is greater than alcohol and is greater than alkyl. Compared to phenol and phenoxide ion is more stable due to there is no charge separation. Phenol is less stable due to separation of charge, and it contains positive charge also. And as negative means minus I effect and minus group is present or electron withdrawing group is present, acidic nature of the substrate will be increases. As plus I or plus M group will increase, means electron releasing group will present, acidic nature of the substrate will be decreases. And compared to orthonitrophenol and paranitrophenol, orthonitrophenol is less stable than the paranitrophenol due to the intramolecular hydrogen bonding. And some important reactions. When phenol react with the sodium metal or act, it gives sodium phenoxide and liberate hydrogen. It is a reaction with metal, and it's an identification test for alcohol also. And when phenol is combining with the sodium hydroxide to form salt or sodium phenoxide and H2O. Phenol is combining with the sodium hydroxide to form sodium phenoxide and water. And when phenol is treated with the acyl halide in the presence of pyridine, it gives phenyl acetate. This is called as a reaction with acyl halide. When phenyl acetate is heated with the presence of anhydrous aluminum chloride in the presence of carbon disulfide, it is involving rearrangement. Acetophenol treated with the anhydrous aluminum chloride in the presence of carbon disulfide, it gives 2-hydroxyacetophenol and 4-hydroxyacetophenol. In this reaction, this 4-hydroxyacetophenol is the major one. And this reaction is called as a Fries rearrangement. And benzylation. When phenol is treated with the sodium hydroxide, it gives acetophenol. This reaction is called as a benzylation. Halogenation. When phenol is treated with 3 moles of bromine in the presence of carbon disulfide means non-polar solvent, it gives orthobromophenol and parabromophenol. And when phenol is treated with 3 moles of bromine in the presence of water means polar solvent, it gives 2,4,6 tribromophenol. This is identification test or distinguish test of phenol from alcohol. It is in white in color. Reaction is called as a halogenation. Nitration. When phenol is treated with a dilute HNO3, it gives orthonitrophenol and paranitrophenol. In this major product is orthonitrophenol. In this only major product is orthonitrophenol. In remaining all the reactions, paranitrophenol only the major product. But in this reaction, means nitration reaction, paranitrophenol is the minor one. And when phenol is treated with the concentrated nitric acid, it gives 2,4,6 trinitrophenol. Means it is also called as a picric acid. And it gives quinol as a major product, and in this 20% only it gives picric acid. It is not possible to synthesize. It gives picric acid, but it gives major as a quinol. To obtain picric acid, we should follow a reaction, that is nothing but when phenol is treated with the H2SO4, it gives phenol benzosulfonic acid. This reaction is important to decrease the reactivity of the benzene. Due to the presence of electron releasing group, the reactivity of the benzene will be decreases, so it can't produce quinol as a major product. And benzene sulfonic acid is when treated with the HNO3, it gives 2,4,6 trinitrophenol. It is also called as a picric acid. In this method, 2,4,6 trinitrophenol means picric acid is obtained as a 100% and as a major product one. When phenol is treated with the H2SO4 at 298 Kelvin, it gives orthosulfonic acid, orthobenzosulfonic acid and parabenzosulfonic acid. And the reaction is Kolb's electrolysis. When phenol is treated with the carbon dioxide, in this carbon dioxide acts as a weak electrophile. In the presence of strong alkalis, it is involving in electrophilic substitute reaction to give orthohydroxybenzoic acid. It means salicylic acid. When phenol is treated with the sodium hydroxide, first it gives sodium phenoxide. In this reaction, it is called as a sodium phenoxide. And further it is treated with the carbon dioxide. In this carbon dioxide, it acts as a weak electrophile, and further acidification, it gives salicylic acid. It is called as a sodium. And this reaction is called as a Kolb's electrolysis. And some Kolb's electrolysis applications are there. It's nothing but when salicylic acid is treated with the acetic anhydrous in the presence of H2SO4, it gives acetyl salicylic acid. It is also called as aspirin. It is used as an antipyretic and analgesic. Some examples are there. When salicylic acid is treated with the phenol in the presence of H2SO4, it gives phenyl salicylate. And salicylic acid is treated with the methanol in the presence of acid, it gives methyl salicylate. If in this reagent, if ethyl is there, it will replace the methyl and it will come ethyl salicylate, like that. And next one is the Riemann-Tiemann reaction. When phenol is treated with the CHCl3 means chloroform in the presence of alkaline, it gives intermediate. By the acidification, salicylaldehyde is formed. So when phenol is treated with the chloroform in the presence of sodium hydroxide, first it gives intermediate. Further acidification, it will give salicylaldehyde. This reaction is called as a Riemann-Tiemann's reaction. In this reaction, electrophile is the dichlorocarbene. Example of this Riemann-Tiemann's reaction is when When methoxyphenol is treated with a chloroform and NaOH in the presence of acidification, it gives as a product as this one as a major product. And next one is the coupling reaction of phenol. When diazonium salt is treated with the phenol at pH 9 to 10, it gives diazo salt. It is in orange color. It means when phenol is treated with the diazonium salt of at pH 9 to 10, it is involving in the coupling to give para-hydroxyazobenzene. This reaction is used to distinguish phenol from alcohols. And condensation of phenol with phthalic acid. When phthalic acid is treated with the phthalic anhydrase, it gives phenolphthalein. And next one is the reaction with zinc. When phenol is treated with the or heated with the zinc powder, it gives benzene. And next one is the oxidation of phenol. When phenols are treated with the oxidizing agent like acidified potassium dichromate or sodium chromate or chromic oxide, it is oxidized as a quinone. This reaction is called as a oxidation of phenol, and when it is exposed to atmospheric air for a long time, it gives pink colored quinone. And at last one, reaction with the ferric chloride. When 3 moles of phenol is treated with the ferric chloride, it gives ferric phenoxide. It is in violet color. And the chemical properties and the physical properties of the phenols are same as the alcohols.